achieves its astounding fuel economy thanks to a powertrain that combines a highly efficient three-cylinder gas-powered engine with a starter generator and electric motor. The starter generator works with the twin-power turbo engine to drive the rear wheels. BMW calls this system eDrive. The powertrain can crank out 357 horsepower. BMW chose to develop the entire powertrain in-house for the i8. An electric motor consists of an interior housing, stator, and a rotor. The stator is fitted with copper windings, placed in a series of phases around the diameter. A device called a coil winding and inserting machine winds 12 coils of copper at a time for a total of 24 coils. Each motor gets over a mile of wound copper. To maximize quality and performance, the wires must be as close to each other as possible. A robot transfers the stator to a station, where the copper windings will be installed. BMW is able to make their motor unusually small, thanks to a specially designed winding configuration. This saves space while helping the car maintain a low curb weight. The copper in an electric motor must be wound as compactly as possible. To ensure this, manufacturers use a highly specialized sewing machine to bind the wires tightly together with 45 feet of cord. BMW's goal is to make every aspect of the i8 as efficient as possible. Thanks to the plug-in hybrid system, the car can travel up to 23 miles on electric power alone. A forming machine uses clamping jaws to manipulate the top of the stator into the correct shape. This helps make the copper coils, insulating paper, and binding cord as tight as possible. Before the stator reaches this station, workers have already inserted each bundle of wires into a color-coded sleeve. Each of the three colors, red, black, and white, identify a different set or phase of the copper coils in the motor. Next, the stators are heated to 329 degrees. Then a robot lowers them into a vat of resin. It's very important that the components of the stator remain as rigid as possible. Coating the stator in resin helps hold everything in place, maximizing the motor's efficiency. The motor has to be as efficient and powerful as possible to boost the three-cylinder engine and give the vehicle the power output of a supercar. Next, a team of robots build the rotors. They are composed of 6 discs. Each disc has 12 small magnets and 12 large ones. The completed rotor will have a total of 144 magnets. The robots offset the magnets as they insert them into the discs, creating a seamless transition between magnetic fields. This is so the motor will run smoothly. Once the robots have aligned the discs and joined them together, they are heated to 150 degrees in an oven. Heating the discs expands the central bore, making it easier to insert the rotor shaft. The rotor shaft has been cooled with liquid nitrogen to negative 190 degrees. The stator, rotor, and the inner and outer housing come together to form the motor. BMW calls this the E-machine. A technician works with a robot to install the power electronics on the finished E-machine.